Hi and welcome to lecture 13. In this lecture we'll talk about scope. Scope of variables, scope of constants, scope of blocks. So the way scope works is as follows. Methods and classes begin new scope for variables, which means that the outer scope variables do not get carried over to the inner scope, and you could always use local variables method to see which variables are in and which variables are not in the current scope. So for example, we have a v1 variable defined outside of a class, and let's define it to a value outside. If you try to use this variable inside the myMethod method, and you try to print it out, you'll get an exception thrown because myMethod has no idea about this variable called v1. You could of course define a new variable called v1 inside the method, and then when you print it out, you'll get the value of inside. And you could also print what local variables are available inside this method, which is your scope. And you'll see that v1 is available inside the scope, which is this v1 over here. Now, you could of course print v1 outside of a class, and you'll get the outside because that's the same scope. And if you print local variables at this point, you'll get v1, and you'll also get object, which is this variable, which was just defined a few lines ago. So that's how variables work. Now, constants are basically any reference that begins with uppercase, including classes, modules, or any other constants. And the constant scope rules are different than variable scope rules. The inner scope constants can see constants defined in their outer scope, and they could also override outer constants. Although outside of that inner scope, the value remains unchanged for constants. So let's see an example. Let's say we have a value of pi, which starts with an uppercase letter, that's all that matters, and you define that as 3.14, and then you want to use that all the way inside the class test2, inside the method what is pi. That's fine because it's a constant. You wouldn't be able to do it with a variable, so in this case you got an exception thrown, but you could do it with a constant without a problem. Now, if you have a constant called myConstant, and then you override the value outer constant in here, and myConstant inner constant prints out inner constant, but outside that constant is still known as outer constant. So the point is, you could use it, but once you define it as a new value, that value becomes the new value of a constant. But when you go back out to the outer scope, you're back to the original value. Now, the changing the value of a constant is kind of weird because the whole point of it is that it should be a constant. So, for example, the value of pi will probably be the same value, and you probably don't want to be changing it, but I'm just pointing out the way it actually works. So if for whatever reason you see some behavior and you're not sure why it's happening, the first thing you should check is, are you naming your variables correctly with lowercase, or are you naming them with an uppercase, in which case it's a constant, which means it has this behavior. Now we move on to the scope of blocks. Blocks are not like methods, so the variables in the blocks actually inherit the outer scope. And this is beyond this lecture, but a block actually is a closure. It remembers the context in which it was defined and uses that context whenever it is called. But just to show you an example specifically for the scope portion, let's say you have a class called bank account, which maybe has an ID and an amount that you are putting into the bank, maybe that you're instantiating a bank account with. And then you have an array of 3 different bank accounts, maybe an amount 200, 100, and minus 100. And then you want to add up the amount in all those 3 accounts. So you have a block here, and you have a total sum variable, which starts out as 0, then total sum gets values added or subtracted from it, and then at the end you print out the total sum variable. So if this would be a method, total sum would be a totally different variable, and you wouldn't be able to do this. But because it's a block, the scope for the total sum is the same. It gets inherited here from the outside, and you're able to keep adding to the total sum variable and print it out at the end, so the variable actually is affected. Now, having said that, that is the default behavior. But even though blocks share the outer scope, a variable that's created inside the block is only available to the block. The parameters to the block are always local to the block, even if they have the same name as the variables in the outer scope. And finally, you can explicitly declare block local variables after a semicolon in the block parameter list. And let's see an example for all three of these on the next slide. So you have an array with a bunch of values. You have a current number, which is 10. But current number is also a name of a parameter to the block. Because of that, when you're looping through the array of 541, the current number is 541, which gets printed out here. And the current number is still 10 on the outside. So because the parameter to the block is current number, it is actually not accessible inside the block because you named it the same, so the scope does not go inside the block. Also, the sum var variable, which you happen to create inside the block, is not accessible outside of a block. So even though usually the variables from outside of the block go into the block, their scope is inherited inside the block, it doesn't work the other way around. The variables declared inside the block actually do not propagate outside. And the final example is we have this variable called adjustment. Adjustment equals 5. And we're doing something with an adjustment inside. We're setting the adjustment to 10. Based on what we just said, the value of adjustment should be affected. And when it's outside, it should be 10 because it got changed inside the block. But we can declare after a semicolon that we want certain variables to be local even though they have the same name as the outside variables. So happens to be this variable is called adjustment, and we're using a variable called adjustment inside the block. So this basically is saying treat this adjustment variable as a local variable, not as a variable that gets inherited from outside a block. In summary, methods and classes start a new scope for variables. Constants maintain scope, so a constant coming from outside of a method or a class will retain the scope, and you're able to access that constant even though it was defined outside of a class and outside of a method. Blocks usually inherit the outer scope, but we talked about ways how you could override that if you want. Next, we'll talk about access control for methods.